Once again, good afternoon, everyone.
Good afternoon, sir.
Yeah. Now, today we are going to learn, we are going to discuss about Q data structure, QADT, Q abstract data type. Here, I hope everyone is understood stack data structures and its applications. Is it right? Yes. Everyone is understood stack data structure as well as stack application conversion from input to
Yes,
FIFO.
sir. Yes, sir.
Yeah. Now, today we are going to discuss about the queue data structure. Here, once the queue data structure, if we are going to discuss, your first unit is going to complete. So that is what. One more thing also I will tell you here. This once we are going to understand this queue data structure, we are going to discuss about implementation of queue data structure. That is also there in your laboratory experiment. That is a fourth experiment. One, two, three, four. Fifth experiment. This is the fifth experiment. Means the first one is single linked list, circular linked list. Third one double linked list, and stack implementation is the fourth one. Now the fifth one is queue implementation. Means 50% of the laboratory syllabus almost. I think is 12 or 13 experiment. I don't know. Almost 40% of the laboratory experiments we are going to finish from this first unit. So that is what you more concentrate first unit. Here we can have double knowledge, maybe double benefit. Okay, understand? Okay, understand what I am telling is clear now, everyone.
Yes, sir.
Yeah. Now we will discuss about queue data structure. Now my screen is visible.
Yes, sir.
Yeah. Now I think everyone know queue. Sure, don't come to the technical term. You come to the queue. Here, when we are going to observe, when we want to take a movie tickets, you must form one queue. When we are going to enter some hall, or maybe the examination hall, or maybe the any etc. Anything we wanted to plan on systematic manner, we must form a queue. Correct? Yes or no?
Yes, sir.
When you want to pay examination fee into the examination branch, compulsory you must follow one queue. Is it right or wrong?
Exactly. Yes, sir.
Yeah. Here same meaning also, same meaning I am taking here, same way of presentation I am considering and implementing queue abstract data type. That's why here don't think for other way. It is simple. Here we are going to automate whatever the manually we are doing. We are going to automate using this queue data structure. How we are following the rules for queue, same rules we have to follow. Now tell me here, for example, here now I am forming one queue. For example, one element is coming. For example, first element. The first element is come 4. Next is coming 3. Next is going coming. Uh, Please follow. Any doubt is there? You ask. This theory, if you understood, then you can understand very clearly queue data structure. So this is the order it is coming. First, what it is came? First,
Four.
the alternate person number is 4 E came. Then here just I am forming one queue. The queue is like this. Who is going to first insert into the queue? Who is going to enter into the queue first?
Four.
4. Please, questions are very clear. If you understand those questions, you can understand queue data structure story. Okay? Right. Now, next one.
P.
Sorry.
P, sir.
When we are inserting 4, what we have to follow? Where we are inserting? Next, we have to insert 3, right? Next, third person has to enter into the queue. Yes or no?
Yes, sir.
From where? From here he is entering from end or from front?
From
So any queue is there. For example, one queue you are following. Maybe you feel this is a counter. Okay, this is a counter. Now fourth person has escaped. Okay, now in flow, third person has he has to enter into the queue. So from where he has to enter?
end.
From
End.
end. Yes or no? Because first which person has came? First which person has came? Initial 4.
Four.
That's why he is the first. Next order is 3. Person has came. That's why always the person here enter from this way. Yes or no? That is nothing but end, right?
Yes,
End of the queue. Yes or no? We cannot enter the front of the queue when we are going to do some work in a queue format. If the person cannot join in the front or in the middle. Yes or no? He has to join always from end. Yes or no?
Yes, sir.
Yeah. Next, which person has came? 7. Sure. Where he has to join?
After 3 from the end.
After 3 or middle or front?
After.
After 3 only. This is the rules. Yes or no? When you have to follow queue, you have to follow these rules. Yes or no? General queue I am asking. Yes or no?
Yes, sir.
Yes, sir.
Yes,
Yeah.
sir.
Yeah. Next to 5. Now he is entered the same way. Just now like this. Correct. Correct.
Correct.
Now the first person. Yeah, this is what? Now he started. He started to providing movie tickets. Now he will give which person? He will give 4, 3, 7, 5. Which person he will give that? He will issue the ticket. 4. 4. Means why he is issuing ticket to 4? Tell me.
He's standing at the first.
Yeah. This is a front. This is called front. Yes or no? Yes or no?
Yes. Yes, sir.
Now, sure, once he is going to issue ticket to fourth person, now what happened? This fourth person must be out of this particular queue. Yes or no? Because he got the invoice and he out of the queue. Yes or no?
Yes, sir.
Now, in this case, what is the end? This is the end. Understand?
Yes, sir.
Now, after this deleting, after this getting invoice from the counter is out of the queue. Correct? Yes or no?
Yes, sir.
Now, what is the front now? After out of the queue, what is the front? Front will
3.
become by 3. Correct. Very good. Now, again, he is going to issue that invoice to 3. Once it will come, then 3 is out of the queue. Wherever, maybe out of the queue. It is not following queue. Yes or no?
Yes, sir.
Now, front will be next person, 7. Yes or no?
Yes, sir. Yes, sir.
After some time, maybe Here 9 is arrived. Now where we are going to insert? From this starting position or ending position?
From ending, sir. After 5.
Means after 5 you will join. Now end will be not 5 now. What is end now?
9.
9. Now understood, this is the queue structure. Whenever you follow, wherever you follow, you must follow the structure, right? Generally, even in bus or even any reservation counter, or even if you go for hospital for consulting of doctors, or if you pay examination fee in your examination counter and railway reservations, everywhere we are following this queue. Yes or no? Yes or no? No reply.
Yes, sir. Yes,
Yeah.
sir.
Now, it means this is very important data structure. Whenever you want to use such type of mechanism, then we need a automation system that is called queue data structure. Now, based on this example, I can tell what is a queue. Your queue is a linear data structure. Yes or no? It is arranging elements in a linear fashion or not? Based on this example, we are arranging the elements in a linear fashion
Yes,
or
sir.
not? Yeah. So now compare linear one by one, one by one, one by one. That's why it's the linear data structure. Now, Q is a data structure which follows linear fashion, and insertion is takes one end and deletion is takes one end. Yes or no?
Yes, sir.
So insertion always from end, correct? Inserting element
Yes.
always from one end. Yes or no?
Yes, sir.
So deletion always takes another end.
Friend.
It is called front. Yes?
Yes, sir.
Yeah, in this data structure, the insertion is one end, which is called as rear. Rear. The technical term is rear. So the deletion always from front side. Okay. So the technical term is front only. Okay. Okay.
Okay, sir.
Now, in this case, what is the difference from queue to stack? Your insertion deletion takes only one end, that is called in a stack. But queue, in a queue,
2 different ends.
yes, one end is for insertion, another end is for
Deletion.
deletion. Understand?
Yes, sir.
When we are going to observe, this insertion is called as NQ. Sure. Whenever you are inserting element into the queue is called as NQ, ENQUE, NQ, enqueuing the element, enqueuing. Here in stack, what do you call? It is push. But here NQ. Here when you want to delete element from the queue is called as DQ, DEQUE, DQ. DE means DQ, deleting the element. Clear? DQ and NQ, two operations. Like push and pop in a stack. Understand? Understand everyone?
Yes, sir.
Now one more. Now the queue also follows one principle. What is that? Here, which element is first come in this queue here? Which element is first come?
4.
4. Now when you want to delete, which element is come out?
4.
4. Means the principle is what? First in, first out principle. First in, first out order, or last in, last out order. Understand the difference between stack and queue?
Yes, sir.
Yes,
Stack,
sir.
stack follows first in, last out, or last in, first out order. Queue follows the element which is first in, that element is going to out first. The element which is came last, that is going to out last. Are you clear?
Yes, sir.
Here, these data structures are very important. Here, further subjects, whatever we are going to study, here everywhere they will tell that Dequeue. Then you can get all this information. Then you can understand the advanced subjects. That's why please practically learn. Okay. At the time of discussion of advanced, then if they tell ask Q means if you don't know, you are feeling like you cannot understand anything. Clear? These are the basic knowledge required in the computer science department. That is what I am very clearly I am mentioning. Understand? Understand?
Yes, sir.
Yeah. Now, what is a queue? Queue is a linear data structure. Your insertion and deletion takes in a different ends. So whenever you want to insert any element, you must be insert through rear of the queue, which is called as enqueue. Whenever you are going to perform deletion, you can perform through the front of the queue, which is called as Dequeue. Always queue follows first in, first out principle or last in, first out principle. Clear the definition of queue, everyone? Everyone is clear?
Yes.
Yes, sir.
Yeah, so this is the way. Yeah, rear and front. Okay, okay, NQ and DQ. NQ is nothing but inserting the element, the function name you can call NQ. Whenever you want to delete, then you can use the DQ. Here, this is the just names, technical names in a queue. Okay, you have to use these names only. Then only it is a good way of representation as a computer science engineer. Clear? Clear? Clear?
Yes, sir.
Yes,
Yeah.
sir.
It follows first in, first out order already you know, right? So just if you observe these elements you want to insert, generally some mechanism we can understand here. Now I want to insert. Initially Q is what? Tell me. Initially Q is, are you clear?
Empty.
Initially Q is empty. Very good. If initially Q is empty means no element is there. Then we need two pointers for Q. Here one is front is representing to beginning of the queue and rear is representing to end of the queue. Now initially the queue is empty, front rear is points to nothing. Means it cannot return, it cannot be represent anything. Yes or no? Yes or no? Yes or no? Hello? Yes or no?
Yes, sir.
Now, initially, the first element which it has came, what is the element? 25.
25.
Now you have to insert 25. So if you are inserting 25, now front and rear is same location. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Only one element is there. He is the first person, he is the last person. So that's why front rear is pointing to same element. Yes or no?
Yes, sir.
Right.
Yes, sir.
Next element as came 30 as came. What happened? Here when 30 is going to, from where it is going to insert, always when I want to insert, the element is insert from
Rear.
rear. That's why rear has to increment first. Then you are going to insert 30. Understand? Understand?
Yes. Yes, sir. Yes, sir.
Next 51 you want to insert. From where? From rear only we have to insert. Then rear is going to increment, means prepare the location and element as inserted. The next 60 has to insert, again from rear only. In this case, when you are inserting, your front cannot be rotated, only rear will be moved. Correct? Understood?
Yes, sir.
Now, here 60. Now, one more element you want to insert, that is 85. Again, rear is going to move. Understood?
Yes, sir.
When someone wanted to delete, means DQ. Now, what should we do? What should we do? From where the element is going to delete?
Front.
From front, the element is going to delete. Means the front is going to move now. Now front will be moved. Now tell me how many elements are there in this queue now?
4.
Because in a queue you must follow front to rear. Okay, here we cannot consider because queue must be follow the elements, the number of elements, the displaying of the elements always must be front to rear. That's why 4 elements only. Understand everyone?
Yes, sir.
Yeah. So this is the way what we are performing in real time queue. Same thing we are going to apply for implementation of Dequeue. Understand? Understand? Is it clear?
Yes, sir.
Right. Here operations. Here we can perform 3 operations on queue. Here one is Enqueue, means inserting the elements into the queue. Next one is the Dequeue, nothing but deleting the element from the queue, and a display, means we have to display the elements in the queue. Clear?
Yes, sir.
Clear. Yeah. Now, in the same way, queue data structure also we can implement using array and using linked list. Using array as well as using linked list. Right? Right. Yes or no? Yeah. Here, simple how you learn to implement the stack using array, using linked list. Same way we are going to learn queue implementation using array and using linked list. Here already we know we are going to apply, we are applied stack rules on queue, stack rules on linked list. In the same way, now you understood rules of queue, right? You understood or not? Rules of queue.
Yes, sir.
Yes, sir.
Now
Understood.
these rules just you apply on arrays and apply on linked list. Then you are going to convert your array to the queue. You are going to convert linked list to the queue. Here, this is the meaning. Here, nothing is there. Same way, if you understand rules, same rules we have to apply. Okay. Here, today we are going to finish at least queue data structure implementation using array. Are you clear? Are you clear?
Yes, sir.
Yes, sir.
Yeah, just we are going to observe here how the procedures will come in a queue. Here, just I am feeling this is a queue. Okay, now here we are converting, means we are applying our queue structures, queue rules or queue principles on array. You know, array is which type of structure? Tell me. Array. What is the rules of array? Tell me, anyone? I'm asking array structure. What is an array? Are you there? I'm asking what is an array?
It is just a collection of elements of same data type which are stored in contiguous memory locations.
There one more point you are missing. I told you. Maybe you don't know in first year, but I given many times. Sir, before using array, you must define the size of the array. This is very important point for our data structures. Are you clear?
Yes, sir.
Yes, sir.
Yeah. So now that's why the array is having static nature. Yes or no? That is why array is having
Yes, sir.
static nature. Yes or no? Same thing we discussed in the stack also. Same thing I am using here. Nothing is different. But rules are different. Procedure is same. Clear? Clear?
Yes, yes, sir.
Now my array size I declared 5. Now what is the queue size? My array size I declared 5. Then tell me what is the queue size? I declared my array size is 5. Then tell me my queue size or how many elements is going to accept my queue.
5.
5, sir.
Yeah, it's simple. Okay. Here, so that's why my queue size is 5. Right. Here, when I cannot insert element in a queue, here this is using array. Please mind you. Please remember. Please use some brain. Okay. Uh, the queue implementation using array, please. Okay. Remember this and give the answers. Now, how many element? Which case we cannot insert the element? Okay, first of all, listen carefully. Now, if it is array, we are declared, and same thing, this is 0 indexing, 1 indexing, 2 indexing, 3 indexing, 4 indexing. Already you know what is the rules of the queue also. Right, tell me. Now, when the queue is empty, when the queue is empty,
When no elements are
when there is no element in a queue, it is empty, right? Very good. But logically tell, here when stack is empty, using array implementation, when stack is empty,
when top is pointing to -1.
top equal to -1. Very good, nice. Who is this? I know, who is this?
Yogita, sir.
Yogita. Yeah, tell me, Yogita. Anyone, others also. Good answer. Now you identified through one logic. Now tell me here how to identify when the my queue is
Front
empty.
is front is equals to minus.
Yeah. From where you are inserting generally, tell me. From where you are inserting?
And
In queue, front or rear?
Where is equals
Rear.
to minus 1.
Rare.
From rear, right? We are inserting from rear always. So this is insertion end. This is deletion end. Understand? So from where you are inserting? From
Rear.
rear. If you identify rear, just I am taking rear for R, front for F for my convenience, please. Here rear equal to -1, then easily you can identify. The stack is, sorry, the queue is
Empty.
empty. Why -1? Already I told you. Even though we can tell front equal to -1 also said. If you tell front equal -1 also, the queue is empty. Yes or no? Yes or no? Front is not having any element. From front side also we can watch. From rear side also we can watch in a queue. Yes or no? Yes or no?
Yes, sir.
Any condition is true. If both the condition is true, also my queue is empty. After watching from front side, you can tell queue is empty. After watching from back rear side, also we can tell the queue is empty. That's why you can take any one condition also not a problem. Both the conditions also not a problem to identify your queue is empty. Correct? Correct.
Yes, sir.
Now I want to insert one element. Please, follow this structure ADT representation, Q ADT representation. Then implementation, program logic wise we will discuss. First of all, understand the procedure. Now I want to insert 4. So from where I have to insert?
Rear.
From rear we have to insert. Means here I don't know the stack is empty or not. Simple. If you are going to insert 4, from where you have to insert, then you can increment rear plus 1. Yes or no?
Yes, sir.
The rear equal to rear plus 1. If rear equal to rear plus 1, what happened? Here rear comes here. Are you clear? Please observe the point. Here. Yes or no? Rear equal to rear plus 1. What is the meaning? Rear equal to rear, how much? -1 plus 1. Then rear points to what? 0 indexing. Correct?
0.
Rear is pointing 0 index means rear is pointing to this location. Yes or no? Yes or no?
Yes, sir.
Then we can write Q of R equal to this 4. Then 4 will be inserted in this location. Yes or no? Yes or no?
Yes, sir.
But what is front still?
4.
No, no, no. As per your logic, we are incremented only rear, right? Here.
-1.
Rear equal to rear plus 1 only we are incremented because what is your logic? Here, just I am going to insert from rear only. What is the need to front? But front is pointing to -1 only. If front is pointing to -1 means no element is there actually. Yes or no?
Yes, sir.
Yes. So that's why when we are inserting a new element into the queue, first of all we have to check front equal to -1, rear equal to -1. Both the conditions we have to check. Here now you can fix up the front is the queue is empty. Now when I am inserting a element at the time of queue is empty, what should we do? Here we have to increment front equal to front plus 1 and rear equal to rear plus 1. Later, you have to write Q of rear equal to that element. Understand? What is the meaning? Are you following? Are you following? Hello?
Yes, sir.
Yeah. Now, front incremented by 1 means front equal to -1 plus 1 means 0. Front is pointing to this. And rear equal to incremented by 1 means rear is pointing to 0. Yes or no? Now we are going to insert Q of rear equal to element 4. Correct? Is it right? Is it right?
Yes, sir.
Yes, sir.
Now next element 7 I want to insert. Now again the condition, what is the condition? Front equal to rear equal to -1. It is false. Correct? Yes or no? Now front is -1, rear is -1. No. Then it is false. In this else part, what should we do? Here we have to check. We have to check one more condition. What is that? Q is full or not? How to check Q is full or not? When we are not going to full, when we are not inserting, when Q is full. That is called overflow condition. You know in a stack how to write. Tell me. Hello? Are you following? Are you following?
Yes, sir.
Means what happened? For example, Q is full is like this. 7, 8, 9, 10. Now what is rear now? This is rear, correct? Is it right or wrong?
Yes, sir.
Yeah. Now, in this case, now I want to insert 11. Is it possible?
No, sir.
No, sir.
Then logically tell me, now when I am trying to insert 11, what will get? Which error? Q
Overflow.
overflow. Then how to identify this overflow? What is the logic?
Rear.
Rear equal to size -1.
Rear equal to max -1 or size -1 or any symbol -1. Yes or no? Then Q is full. Then we cannot insert this element. Yes or no? Yes or no?
Yes, sir.
We have to check overflow condition. Then otherwise, now I want to insert this 7. Now in this case. Now in this case, front equal, rear equal -1 is false. And the stack overflow is false. Then only the simple condition what? From where you have to insert? From front or rear?
Rear.
Rear.
Rear. Now just we can use rear equal to rear plus 1 and Q of R equal to element. Yes or no? Now 7 will come here. Now rare is incremented. Understand? Understand?
Yes, sir.
Right. Now, again, you want to, this is the three ways you can, when you want to insert, you have to take these three conditions with help of array. Now, coming to deletion operation. Deletion operation is what? Dequeue. So, from where we have to delete?
Front.
Front. Now, which case we cannot delete? In which
F
case we
equal to
cannot delete?
-1.
F equal to -1. That is called as underflow condition. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Yeah. Here, next. Next. Now, my queue is contains two elements. So this is front, this is rear. Okay. Now you are deleted first element. What happened? This is rear, right? What happened? Here your front is moved to this. Correct? Sir, I told you it is a static data structure. We cannot delete the element. Just your front and rear is pointing. Okay? Understand? Yes or no, right?
Yes,
Are
sir.
you clear? Now front rear. Now again I want to delete the element. Which element is going to delete? Tell me. Hello?
7.
7. Sure, after 7 deleting, front is moving to its next location. Yes or no? Front equal front plus 1. Are you clear? Are you clear? Yes or no?
Yes, sir.
In a queue, after this, front is moved to this position. Now tell me when front and rear points to 7, then after deleting of the 7, front is moved to after rear. Is it possible actually in a queue? Is it possible?
No.
Means here one more condition we have to check when we have to delete front equal to rear. What is the meaning? If front equal to rear, what is the meaning? What is the
They're
meaning?
pointing to the same element.
Means your queue having only one element. Understand? Understand? Front equal to rear means what is the meaning? Your queue contains
Single element.
single element. Now we are trying to delete. If that in this case, if we are trying to delete, what happened? That element is deleted. But after deleting the element, front and rear points to what?
Null.
Not null, -1. Then in this case also you have to check. Understand? The first case is what? Q is empty. The second case is what? In the time of deletion. The second case is what? The queue contains one element. If the queue contains one element, then directly front equal to rear equal to -1. Yes or no? Means you are deleted. Yes or no?
Yes, sir.
Here, else remaining cases only front is going to incremented by 1 for deletion. Understand? Understand in general way? Understand everyone? Understand?
Yes, sir.
Yeah.
Yes, sir.
Now we will discuss the logical way implementation of queue using arrays. Now, as per the discussion, you know, here you have to define the size of the queue. So here I have taken 6. Now we need 2 pointers. One is for representing the front side of the queue, that is the front. Another one is for representing the end of the queue, that is the rear. Here initially both are -1 because your queue is initially empty. Yes or no? Are you clear? Are you clear?
Yes, sir.
Now these three operations. Addition means enqueue, deletion means dequeue, and display. Now this method, this mechanism, this while loop main method, you know, that we have to ask end user you want to add or you want to delete or you want to display or exit. This switch case, same switch case we can use whatever you used in the stack, same switch case we can use in the queue. Fine? Is this fine? Is this fine?
Yes, sir.
Right. Now come to the Enqueue, means inserting element into the queue. Right. Here initially, the queue size is how much? 6, right? Here now you want to insert. When you cannot insert, tell me. In a queue, when you cannot insert,
Rare equal to -1.
when the queue is full, because you're starting representation, when the queue is full. Here, when the queue is full, when the queue is full, hello? When the queue is full, how to know the queue is full?
Rare equal to max
Rare
minus
Rare equal to max -1. For example, my queue size is, please imagine only 4 I am taking for my consideration. 4, please. These are a very important data structure. Okay, this is front, this is rear. For example, already elements are there. 4, 5, 8, 3. Now rear equal to -1 means 0, 1, 2, 3, max -1. Correct? My max is 4 only. Correct? Hello? Is it fine?
Yes, sir.
Rear equal max -1. Okay. Some people will confuse. For example, I will tell you. Here, for example, I deleted one element. What happened? Front is, what happened? I deleted one element. Which one is, what happened? Tell me. Hello? I deleted one element. What is the procedure? Tell me.
F equal to F plus 1.
Front is incremented by F will come here. Very good. With the drawback also I am telling here. Actually, advanced data structures are not there. I will give the drawback also here. Now again I deleted front. Now tell me how many elements are there here? How many elements are there? In this queue, how many elements are there? In this queue, how many elements are there?
3.
2, 2.
2 elements only. Yes or no? Front to rear, how many elements?
2 elements.
2 elements are there. But what is the queue size?
4.
4. But is it possible to insert? Now I want to insert element. Now I want to insert 7 now. Is it possible?
No, sir.
Why? Always we have to insert from where? Rear. Now rear is pointing to what?
3, sir.
3.
Don't tell 3. Max -1.
Okay.
Yes or no?
Yes, sir.
Now it is not possible. But only 2 elements are there. Here, this is the drawback when we are going to implement a queue using array. Here it is not there in the using linked list. Clear now? Clear. Placement people ask this type of question. That's why this example I given here. Are you clear?
Yes, sir.
Yeah, this is the case we cannot insert. Means when rear is pointing max -1, the remaining whatever it is, here it is not possible because we have to insert always from rear in a queue. Understand everyone?
Yes,
Understand
sir.
everyone? This is the only one case. The case is rear points to max -1. Here now, no. My queue is not empty, not full. It's overflow because it is not pointing to -1. Maybe it is pointing to here. This is rear and this is front. Now it moves to the else part. Are you clear? Are you clear? In other cases, Three cases are there, already I told you. Now front equal to rear equal to -1. So now, when my stack is, when we can insert in a queue, when we can insert element into a queue, are you there?
When rear is not equal to maximum.
When rear is not equal to maximum. That's why you move to the else part. Here in this else, we have two options, because if queue is empty or queue is not empty. Here, if queue is empty, what is the problem? You have to increment front as well as rear also. Yes or no? Just now we discussed. If queue is not empty, just we can increment rear and you can insert it from the rear. But when queue is empty, you have to increment by 1 to front and you have to increment rear also. Then you can insert element into the queue from the rear of the queue. Are you clear? Are you
Yes,
clear?
sir.
So that's why I'm checking my queue is empty or not. How to know the queue is empty or not? How to know the queue is empty or not? Hello? How to know the queue is empty or not?
So
Front
if
equal
queue
to
is
-1.
empty, front.
You can do both the condition. Front equal to -1 also you can use. You can use rear equal to -1 also you can use. Yes or no? But I have taken here front equal to -1. Even though you can use rear equal to -1 also. Are you clear? Are you clear?
Yes,
Yes,
sir.
sir.
Now I want to insert this element here when the queue is empty. Now if front equal to -1, then queue is empty. Here now I want to insert this 7. Here this is the position maybe I want to insert. Here in this case, we are going to increment front and rear and we have to increment through the rear. So that's why here I've taken front equal 0. Now front is points to what? Indexing of 0. Are you clear? Are you clear? Hello?
Yes, sir.
Yes, sir.
Now from where you have to insert? From rear you have to insert. That's why Q of plus plus rear. Only one line I have taken. Otherwise you can take two lines. Already I told you earlier. Here increment rear equal rear plus 1. Then you write Q of rear equal to element. But I have taken directly pre-increment. That is Q of plus plus rear equal to element. So that's why here rear is incremented by 1 in this case. Are you clear now?
Yes, sir.
Yeah. So this is the way. Here otherwise, for example, no, Q is not empty. Q is having some elements. Here, this is the case. Here front is pointing to 0 indexing, rear is pointing to 1 indexing, and we have the choice because it is not full. If it is full, we cannot insert. This is the third case. Here means here now where we are else part. Now if front equal to -1 in this case, front equal to -1 in this case. Hello?
No, sir.
No,
No.
sir.
If it is no, you must skip the following statement. Yes or no? Yes or no?
Yes, sir.
Means we don't bother about the front because it is not end. It is not empty. Here, when we are going to think about the front, when queue is empty, you must think about the front. Here, when the queue is not empty, you don't think about the front. That is very, very important point. People will confuse. They are going to write same code. Here, that's what. When front equal to -1, when the queue is empty, you must think front you have to assign with 0 when you want to insert. Here, when queue is not empty, here front always showing to some indexing. Don't think about the front. Maybe front is here, maybe front is here, maybe front is here, wherever. Here. It is not a problem for us. That's why we have to think about only for insertion. Are you clear now? From where? Are you clear? Are you clear?
Yes, sir.
Yeah, that's why I've taken front equal to -1. If it is false, you skip the following statement. Means what I am skipping? Front assigning 0 to the front I am skipping. Then again same logic. I have not written different code again. For that also I have taken same logic. What is that? Increment by rare by 1 and insert a new element at q of r equal to element. So now the 7 will come here. Are you clear? Understood now? Understand?
Yes, sir.
Again
Yes,
I
sir.
want to insert one more element. Then my queue is like this. What happened? Now it comes from here. Rare equal to equal max minus 1. Where is in max minus 1 now? No, right? Where is the rare now? Is this condition is false or true? False. Go to the else part. In this else part, if front equal to equal minus 1. Front equal to equal minus 1.
No.
If it is no, skip the
No.
following statement or block. So now increment by rare by 1 and insert at q of rare. Again, I want to insert one more element. Now, what happened? Rare equal max minus 1. True or false? True or false? Hello?
Yes, sir.
True.
If it is true, then following block execute and out of the code. Understood? Inserting element into the queue. Understood, everyone?
Yes.
Yeah.
Yes, sir.
Now, deleting element from the queue. Deleting element from the queue. Here, which case we cannot delete? Tell me, anyone?
Queue is empty, we cannot delete.
Yeah, queue is empty, we cannot delete. Here, what is the condition for checking queue is
Friend
empty?
equal to minus 1.
Even though we can use rare equal to equal
Rare
minus
equal
1
to
also.
minus 1.
Both we can work, but always we are deleting from where in a queue.
Friend.
That is
Front.
why I have taken front equal to minus 1. Understand? Understand? Why I have written understand?
Yes, sir.
Now, here we cannot delete in this case. Here, if my queue having some elements, okay, my queue is having some elements. Now, how to delete? Just I'm taking example. This is front. This is rear. 3, 7, 8, 2. Indexing 0, 1, 2, 3. Now tell me. Now we are in else part. Now, if you want to delete any element, then how to delete?
By
Which element is going
incrementing
to delete?
friend.
Which element we are going to delete?
Front.
3.
Front only. Means front will be incremented by 1. Yes or no?
Yes, sir.
Means front is incremented by 1. Front is moved to here. Correct? Is it right?
Yes, sir.
So again, you want to, please, it is a static representation. Elements in a queue, elements in an array we cannot delete. It is not possible. Just using pointers we are going to identify. We are going to rotate. Are you clear? Yes or no?
Yes, sir.
This is what the logic, plus plus front. Again, you want to delete, you have to write plus plus front. Correct? Correct.
Yes, sir.
Again, you want to delete. Then what happened? You can delete, front is moved out of this, okay, front will be moved to indexing of 4. Just we don't have, but just numbers, right? Front equal front plus 1. F is going to out of the. Then in this case, what happened? It is going to check. Here, all these cases, it never comes to if part. Now, when it is moving to here, now what it will tell? If front is greater than rear, true or false? Not understand? I will tell you.
True, sir.
If you are confusing, then I will tell you. Now tell me. Now, if it is in else part, then what it is the meaning? Plus plus front, we have to do it. Here, yes. Now front will be come after deletion. Now tell me, in this case, front is greater than rear. True or false? True or false? Front is greater than rear. What is the front? 1 is greater than 3. True or false?
False.
False means out of the block. The next element I want to delete. Here I concised my code, reduced my code for unnecessary wasting of the memory. That is what. Don't confuse. Again, I want to delete one more element. What happened? As per the discussion, here it is not empty, then it will comes to the plus plus front. Front is incremented by 1. But again, in this case, it will be checked. Here, what is that? Front is greater than right. True or false? True or false? Hello?
False.
If it is false, out of the block. Here again, I want to delete. What happened? Here it is not empty, then moves to else, then front will be incremented by 1. Yes, front will be incremented by 1. Very good. Now, front is greater than rear in this case?
False.
False, out of the block. Again, I want to delete element. Again, what is the logic? It is not empty, then moves to the else part, then plus plus front. Here, front will be incremented by 1. And front value is now 4. Now, if front greater than rear, true or false?
True.
If it is true, as I told you, means the queue is empty. Yes or no? After deleting of this, queue is empty or not?
Yes, sir.
Because 3 is deleted, 7 is deleted, 8 is deleted, 2 is deleted. Don't think about the array. Array is not empty. Array is empty. Now array is empty.
No.
No, queue is empty. Array is not empty. Here now array is empty. When queue is empty. When queue is empty, what is the logic? Front equal to rear equal to -1. Understood? That's
Yes,
what I
sir.
have written. Front equal to rear equal to -1. A simple logic. Okay, very simple number of lines. If you understood this mechanism, with the lines of code, we can understand very easily. Are you clear how to delete the element from the queue? Are you clear?
Yes, sir.
Yes,
Yeah.
sir.
Now the final one is the display. Here, display means we are going to display the elements. Here, when we cannot display the elements,
Queue is empty.
here, how to know the queue is empty?
Front or rear equal
Front
to 1.
equal to -1 or rear equal to -1. Generally, we are going to delete the element from front. Or traversing always from front to rear. That's why I have taken front. Understand? Traversing always from front to rear. Why? It is a queue, linear data structure. Yes or no? Yes or
Yes,
no?
sir.
That's why I have taken the condition itself front equal to -1. Here, then queue is empty, means underflow. Here, queue is having some elements. Queue is having some elements. Then we have to display the elements. How to display, how to traverse in a queue? How to traverse in a queue?
Using front.
From front to rear. We have to stop at rear. We have to start from front. 0, 1, 2, 3 indexing also. Right? 7, 8, 9, 10. Now we are in else part. Now from where you have to start? You have to start from front to rear. Here already we know whenever we are going to traverse, you don't take front to traverse. You have to assign one temporary variable. Yes or no? Yes or no? Yes or no?
Yes, sir.
That's why I have taken I for traversing in this queue. That's why for I equal to front. Now this is I. Understand? Understand?
Yes, sir.
Now I is less than or equal to rear. True or false?
True.
You have to traverse from front to rear. True. If it is true, following block has to execute. What is that? Print Q of I. Here, what is the Q of I? Means 0. Q of 0. What is that? What is that?
7.
7. Very good. Here, next, increment I value. This I will be moved from here to here. Now, again, check the condition. What is the condition? I is less than or equal to rare. True or false?
True.
If it is true, following statement as will execute. Means print Q of 1. What is the Q of 1? 8. Again, increment. Then I is incremented by 1. Yes or no? Yes or no?
Yes, sir.
Next condition. I is less than or equal to rare. True or false?
True, sir.
It is true, following statement as to execute. Now 9 is going to print. Again, increment. Now I is moved to the next location. Now again condition. I is less than or equal to rare. True or false?
True.
It is true, following block has to execute, that is Q of I. What is Q of 3? 10 is going to print. Then next iteration, I will be incremented by 1. Then I is moving to 4. Now, I is less than or equal to rare. True or false?
False.
It is false, out of the block. If the elements are 7, 8, 9, 10, it is going to print. Means don't feel compulsory always Q is full. Sometimes front is here also, it will be start from here to here only. Understand? Understand? Means your queue contains how many elements? In this case, from front is here. Your queue contains how many elements?
2 elements.
2 elements only. Here it is going to print 2 elements. Everyone is understood this? Implementation of queue using arrays. Understood?
Yes, sir.
Yeah. Please practice on paper with your pen.